Welcome back to Tech Daily. I'm Oliver, and today we're diving into 14 fascinating stories from the AI landscape that paint a pretty contradictory picture. On one hand, we've got this massive enterprise adoption paradox. Forrester's reporting that 75% of enterprise leaders claim they're adopting agentic AI, but most are completely stuck in pilot purgatory. Meanwhile, we're seeing some genuinely breakthrough releases.
And Jane here. And that's exactly what caught my eye too, Oliver. While enterprises are struggling to move past demos, we're seeing these incredible practical wins. Anthropic just reported 80% of their production code is now AI authored with 8x productivity gains. Google's dropping multiple models, including one that runs multimodal inference right on your laptop. There's this weird disconnect between the enterprise paralysis and what's actually becoming possible.
It's fascinating because we're also seeing this fundamental trade-off emerging around speed versus quality. Google's experimental DiffusionGemma can generate tokens 4x faster by processing them in parallel instead of sequentially, but at the cost of output quality. And then you have these self-improving systems that can optimize their own performance without human intervention. The technical capabilities are racing ahead while adoption lags.
Exactly. And what's really exciting is how accessible this is becoming for individual builders. We've got ESP32 projects for tracking aircraft overhead, neural networks running directly in TradingView charts, and open models that are competitive with proprietary ones. The gap between enterprise hesitation and solo builder innovation has never been wider. Today we'll unpack why that's happening and what it means for the rest of 2026.
So let's dig into this enterprise AI adoption paradox. Forrester's data is pretty damning. 3/4 of enterprise leaders are claiming they're adopting agentic AI, but when you look under the hood, most are trapped in what I'd call pilot purgatory. They're running impressive demos of long-horizon agents that can handle extended, multi-step operations, but they just can't seem to make the leap to actual business value.
What's really striking is that this isn't a technical problem anymore. The report makes it clear that long-horizon agents are now technically viable. We're past the 5-minute quick operation limit. But there's this massive organizational inertia. These enterprises have the resources, they have the talent, yet they're stuck while vendors are slapping agentic labels on everything and showcasing flashy capabilities that never see production.
Exactly, and this pattern should sound familiar. It mirrors every previous AI adoption cycle, impressive demos followed by painfully slow real-world deployment. The disconnect seems to be that vendor marketing has completely outpaced enterprise implementation capability. Companies are caught between the pressure to innovate and the reality of integrating these systems into existing workflows, compliance frameworks, and risk management processes.
And here's what I find fascinating. This enterprise paralysis might actually create a massive timing advantage for solo builders and smaller companies. While these huge organizations are trying to figure out how to make agentic AI enterprise ready, individual builders can start small and practical. They don't need to navigate procurement committees or worry about enterprise-scale safety protocols.
That's a crucial insight. The enterprise approach seems to be wait for the perfect bulletproof solution, while the builder approach can be start with what works today and iterate. When you think about it, someone running a portfolio of small AI-assisted businesses doesn't need the same level of institutional safeguards. They can experiment with these agentic systems in low-risk environments and actually learn what creates value.
Right. And there's potentially a huge business opportunity here too. If enterprises are struggling to bridge this pilot to production gap, there's a market for tools and services that solve exactly that problem. Or even better, targeting the practical edge cases that enterprises can't scale down to, but solo builders can tackle directly. The timing mismatch isn't just an observation, it's a strategic advantage for anyone willing to start building now, instead of waiting for the enterprise market to catch up. Now, this is where things get really concrete. Anthropic just dropped some incredible numbers. Minus 80% of their production code in May was authored by Claude, with an 8x productivity increase per engineer. But what's more interesting is how they got there. They've outlined this 3-stage roadmap that any development team could follow.
Before we get to the roadmap, let's talk about those performance numbers, because they're staggering. Claude hit a 76% success rate on complex open-ended engineering problems. That's a 50-point improvement in just 6 months. And we're talking about a 52x speed up on optimization tasks compared to the 4x humans typically achieve. This isn't incremental improvement, Jane.
Exactly, and the roadmap shows how they systematically unlocked that performance. Stage 1 is shifting developers from writing code to architectural oversight. Instead of being in the weeds coding, developers become the architects defining what needs to be built. Stage 2 tackles the bottleneck that emerges: code review. They deployed automated AI code reviewers, and here's the kicker: these reviewers caught 1/3 of historical production bugs.
That code review finding is fascinating because it highlights Amdahl's law in action. Once you automate code generation, the serial processes like review become your limiting factor. But there's something deeper happening here. This is recursive self-improvement in production. Claude is literally improving its own code base. What are the competitive implications when your AI can rewrite itself to be better?
Stage 3 is where it gets really wild: autonomous technical debt cleanup. They turned Claude loose on high-volume technical debt, and it shipped over 800 fixes in what they estimated would have taken humans 4 years. But Oliver, I think the evolution pathway they describe is the real story here. Manual writing from 2021-2023, then chatbot assistants through 2025, coding agents in 2025-2026, and now autonomous agents.
That timeline is crucial because it shows this wasn't an overnight leap. But what strikes me is the quality inflection point. The report mentions AI-generated code quality was objectively lower than human code in late 2025, reached parity by mid-2026, and is expected to surpass human standards. We're potentially looking at the moment AI code generation became not just faster, but better.
And the practical implications are huge. If you're a solo builder or small team, you can implement these 3 stages immediately. You don't need Anthropic's resources. Start with Claude for development, set up automated review processes, and target your own technical debt for cleanup. The architecture is scalable down to individual developers.
But this creates a competitive baseline that's almost impossible to ignore. If Anthropic is achieving 8x productivity gains, how do you compete in software development without similar AI integration? This isn't just about individual productivity anymore. It's about organizational survival. Companies that can't match this velocity will be at a fundamental disadvantage.
The shift in developer roles is the part that really excites me, though. Instead of being code writers, developers become system architects, problem definers, and quality overseers. It's actually a more strategic role. And the recursive improvement aspect means these systems should keep getting better at understanding and implementing architectural decisions.
The recursive element is what makes this potentially unstable for the industry. When your development tools can improve themselves, you get compound acceleration. Anthropic isn't just reporting current performance, they're demonstrating a system that should theoretically keep getting faster at getting faster. That's a fundamentally different competitive dynamic.
Right, and what's practical about their approach is they're not trying to replace developers, they're amplifying them. The 3-stage roadmap preserves human judgment for architecture and oversight while automating the repetitive implementation work. For anyone building AI-assisted businesses, this is basically a blueprint for scaling development capacity without scaling headcount.
This sets up our next topic perfectly, because Anthropic didn't just publish this roadmap, they released the models that make it possible. Their new Fable 5 and Mythos 5 models are specifically designed for this kind of autonomous, multi-day coding work. But as we'll see, the implementation reality has some interesting nuances. So let's dig into these new models that make that roadmap possible. Fable 5 is Anthropic's latest Mythos class model, specifically engineered for multi-day autonomous operations. The technical specs are impressive. It's hitting 90% plus on Cursor Bench and Frontier Bench, which puts it in truly frontier territory for coding capabilities.
What's fascinating about Fable 5 is how it's designed for the handoff workflow. Instead of supervising every step, you can literally give it a complex project and come back days later to review the completed work. It has self-validation capabilities, it writes tests, checks outputs against designs using vision, and can even plan across stages and delegate to sub-agents.
The pricing model is interesting too. $10 per million input tokens, $50 per million output tokens. That's less than half the price of the Mythos preview, which suggests they're trying to make these frontier capabilities more accessible. But there's this clever safeguard architecture where certain queries automatically fall back to the cheaper Opus 4.8 model.
Right, and they don't even charge you Fable pricing when it falls back for cybersecurity or biology queries. It's a smart way to manage risk while keeping costs reasonable. But Oliver, this is where the tiered model gets really interesting. Mythos 5 is essentially Fable 5 with the safeguards lifted, but it's restricted to cyber defenders through Project Glasswing.
That restricted access model is crucial. By limiting the unrestricted version to trusted defenders, they're creating a capability moat while managing dual-use risks. It's similar to how security researchers get early access to vulnerability data, but the performance benchmarks for both models are remarkable. Stripe used Fable 5 to compress 2+ months of codebase migration into a single day across 50 million lines of Ruby.
The vision capabilities are particularly impressive. Fable 5 can beat Pokemon Fire Red with vision-only input. No maps, no guides, just watching the screen. It can rebuild web apps from screenshots and extract precise data from scientific figures. But here's where it gets interesting. When you dig into the practical reviews, there's a clear trade-off pattern emerging.
Exactly. And this is where the benchmarks diverge from real-world performance. A detailed review found that while Fable 5 excels at autonomous, underspecified coding tasks, it actually underperforms on production code review. The precision is lower, -32.8% versus 35.5% for Opus 4.8, and it generates significantly more comments.
That's the key insight. Fable 5 produces 253 comments versus the baseline, and they tend to be more assertive and nitpicky. It matches coverage for actionable items, but the signal-to-noise ratio is worse. So while it's phenomenal at exploration and building complete implementations, it's not ready as a drop-in code reviewer for production environments.
The timeout behavior is concerning too. In benchmarks, 19 out of 33 tasks timed out, but it was still burning through output tokens even during timeouts. This means cost evaluation needs to be based on cost per solved task, not just token pricing. The model seems optimized for depth over efficiency.
Right, and that's actually a feature, not a bug, for certain use cases. If you want an AI that will explore your environment thoroughly before building something, run until it finds a complete solution, and produce full implementations rather than prototypes, then the timeout behavior makes sense. You just need clear stop rules and cost monitoring.
The security capabilities add another dimension. It's better than generic coding models for security-relevant implementation work, but it's not a specialized security reviewer. The strength seems to be when security is integrated into concrete coding tasks rather than abstract security analysis.
What I find most practical about these findings is the use case clarity. Deploy Fable 5 for exploration, planning, and building workflows where you want depth and completeness. Keep your existing reviewer for production code until the precision improves. It's a specialist tool, not a generalist replacement.
The memory improvements are worth noting too. Fable 5 with file-based memory improved Slay the Spire performance 3 times more than Opus 4.8. This suggests the model isn't just better at coding, it's better at maintaining context and learning from past decisions across extended sessions.
And that's where the multi-day autonomous capability becomes really powerful. Customer testimonials describe senior research scientist-grade reasoning and one-shot app generation. When you combine that level of reasoning with persistent memory and self-validation, you're looking at something that can genuinely handle complex projects with minimal human intervention.
The drug design results from Mythos 5 reinforce this. It accelerated drug design 10x and autonomously designed 9 of 14 protein targets that yielded strong drug candidates. It even generated novel molecular biology hypotheses that were validated by independent research. We're seeing specialist-level performance across domains, not just coding.
What's strategic about this release is that Anthropic is explicitly positioning these as production tools for autonomous workflows, not just enhanced assistance. The 30-day data retention requirement, the enterprise testimonials, the safeguard architecture, everything signals they're targeting serious deployment scenarios where AI agents operate independently for extended periods.
While Anthropic is pushing the frontier with autonomous coding, Google is taking a completely different approach. They're attacking multiple market segments simultaneously with a coordinated release strategy. We've got Gemini 3.5 Live Translate for real-time communication, business profile integration targeting small businesses, and Gemma 412B bringing multimodal AI to consumer hardware. It's like they're trying to own every layer of the AI stack at once.
And each one of these hits a different practical need beautifully. Let's start with Live Translate because this is genuinely game-changing for real-world applications. We're talking about speech-to-speech translation across 70+ languages with near real-time performance. Unlike the awkward turn-based systems we're used to, this generates continuous speech that preserves intonation and pacing while staying just seconds behind the speaker.
The technical achievement there is significant, balancing context quality versus sync latency to avoid those painful pauses. But strategically, Google is positioning this across their entire ecosystem. Developer API, Google Meet, consumer apps, they're not just building a feature, they're creating a moat around multilingual communication that touches everything from enterprise collaboration to consumer travel.
Exactly, and the business applications are immediate. Grab is already testing this for driver-traveler communication across their 10 million monthly voice calls. There's a new listening mode on Android that streams translation through your phone's earpiece without headphones. For small businesses dealing with international customers or remote teams with language barriers, this eliminates a massive friction point.
Which brings us to the business profile integration, and this is where Google's strategy gets really clever. They're giving small businesses a contextually aware AI that understands their specific brand voice, customer reviews, and performance data. Instead of generic AI assistants, businesses get recommendations grounded in their actual Google business profile data.
This is huge for solo builders and small business owners. The AI can draft personalized review responses, update operating hours, analyze monthly performance using real business data. But the Business Notebooks feature is what really excites me. It's like having a persistent knowledge base that remembers context between sessions and proactively surfaces critical action items. No more re-explaining your business context every time you interact with the AI.
That persistent context model is strategically brilliant because it creates switching costs. Once a business has built up that contextual knowledge base, moving to a competitor means starting over. And Google has the data advantage here. They already know these businesses through maps, search, and advertising data. They're not building AI assistants, they're building AI business partners.
And then there's Gemma 412B, which tackles the other end of the market entirely. This runs on consumer laptops with just 16 gigabytes of memory, but it's benchmarking nearly as well as the much larger 26B model. The standout feature is native audio support. It can process raw audio signals directly without separate encoders, which opens up so many local AI applications.
The strategic positioning of Gemma 412b is fascinating because it directly challenges the cloud-centric AI model. By enabling high-quality multimodal inference locally, Google is essentially betting that privacy-preserving, cost-efficient local AI will be a major market segment. They're giving developers the tools to build applications that don't depend on per-token cloud costs.
From a builder's perspective, this is incredible. You could create voice-controlled home automation systems, custom audio processing tools, or multimodal interfaces that run entirely on consumer hardware. The audio capabilities combined with local inference means you can build AI applications without ongoing cloud dependencies. For anyone building AI-assisted businesses on a budget, this changes the economics completely.
When you step back and look at these three releases together, Google is essentially hedging every major AI trend: real-time multimodal communication, context-aware business tools, and local inference capabilities. They're not betting on one future for AI, they're trying to win regardless of which direction the market moves. It's a remarkably comprehensive strategy that addresses enterprise, SMB, and developer segments simultaneously.
Right, and what's practical about Google's approach is they're solving real workflow problems rather than just showcasing impressive capabilities. Live Translate eliminates language barriers. Business profile integration solves the context persistence problem. And Gemma 412b makes advanced AI accessible without cloud costs. Each release targets a specific friction point that's holding back broader AI adoption.
Now here's where Google gets really experimental with their approach to the speed versus quality trade-off. DiffusionGemma is a fascinating technical departure. Instead of generating text token by token sequentially, like every other language model, it generates entire blocks of 256 tokens simultaneously using a diffusion approach. The performance gains are dramatic: over 1,000 tokens per second on an H100, 700 plus on a consumer RTX 5090.
What's really clever about this approach is how it shifts the computational bottleneck. Traditional autoregressive models are limited by memory bandwidth. You're constantly waiting for the next token. DiffusionGemma moves the bottleneck to compute instead, which modern GPUs handle much better. And at 18GB VRAM when quantized, it actually fits on high-end consumer hardware, which opens up some interesting possibilities for local workflows.
The architecture itself is quite elegant. It's a 26 billion parameter mixture of experts model, but it only activates 3.8 billion parameters during inference, which keeps it efficient. But the real innovation is the bidirectional attention mechanism. Unlike standard language models that can only look backward at previous tokens, DiffusionGemma can process text in both directions, enabling capabilities like self-correction and non-linear tasks that traditional models struggle with.
That bidirectional capability is where this gets practical for builders. It excels at things like code infilling, where you need to fill in missing parts of existing code, and inline editing workflows. I could see this being incredibly useful for interactive development environments where you want rapid feedback and iteration. The model can solve Sudoku puzzles and generate amino acid sequences precisely because it can reason about the whole structure simultaneously rather than sequentially.
But here's the crucial trade-off. Google explicitly acknowledges that output quality is lower than their standard Gemma 4 model. This isn't a strict upgrade. It's a specialist tool optimized for speed-critical interactive workflows rather than production-quality output. The question becomes, when is 4 times speed worth accepting lower quality? And Google's positioning suggests they see this primarily for single-user local workflows, not high-throughput cloud serving.
Exactly, and I think that positioning makes perfect sense for the builder community. If you're prototyping, brainstorming, or doing rapid iteration cycles, speed often trumps perfection. Think about scenarios like real-time code completion, interactive writing assistance, or rapid content generation, where you'll be editing the output anyway. The bidirectional editing capabilities, combined with local inference, could enable entirely new categories of interactive AI tools.
The release strategy is interesting too. Apache 2.0 licensing with support for MLX, VLLM, transformers, and other popular frameworks. Google is clearly optimizing for adoption and experimentation rather than trying to monetize this directly. It feels like they're exploring whether parallel generation can become a viable alternative paradigm, and they want the community to help figure out the optimal use cases.
Right, and for solo builders working on AI-assisted businesses, this represents a completely different economic model. Instead of paying per token for cloud inference, you get local high-speed generation with a one-time hardware investment. The speed gains could make interactive applications viable that wouldn't work with traditional token-by-token generation latencies. It's another piece of evidence that the future of AI might be more distributed than the current cloud-centric model suggests.
Now, this is where we get into genuinely breakthrough territory. Retrospective harness optimization, or RHO, represents a fundamental shift in how AI agents can improve themselves. Instead of needing carefully curated test sets or human feedback, this system improves agent performance using only past execution trajectories. We're talking about a 59% to 78% improvement on Salpusnation round with no external grading required.
What's remarkable about this is it solves one of the biggest practical challenges in deploying AI agents, the continuous improvement problem. Most organizations can't afford to manually curate validation sets or provide constant human feedback to improve their AI systems. But with RHO, your agents literally get better at their jobs just by doing their jobs. Every task they complete becomes training data for the next optimization cycle.
The technical mechanism is elegant. It uses something called deterministic point process to select a diverse subset of past failures for resolving, essentially picking challenging tasks that span different types of difficulty. Then, it resolves these tasks in parallel, uses self-validation and self-consistency to diagnose what went wrong, and finally employs a self-preference mechanism where the agent evaluates different harness improvements through pairwise comparison.
That self-preference mechanism is the key insight for practical deployment. Instead of requiring human judgment about which improvements are better, the agent tests different approaches and picks the most effective ones based on actual performance outcomes. For solo builders using Claude or other AI agents in their workflows, this means their automation setups should theoretically get more reliable and effective over time without manual tuning.
What's particularly fascinating is that this isn't just improving performance metrics, it's actually altering behavioral patterns. The optimized harness maintains higher accuracy during long horizon sessions across software engineering, technical work, and knowledge domains. This suggests the improvements are structural, not just surface-level optimizations. The agent is learning better strategies, not just memorizing solutions.
And that's where this becomes incredibly valuable for production AI systems. Think about workflow automation, customer service bots, or development agents. Any system that performs repetitive tasks with slight variations. Instead of performance degrading over time as edge cases accumulate, you'd have systems that get better at handling those edge cases automatically. For businesses building AI-assisted operations, this could mean the difference between systems that require constant maintenance and systems that become more valuable over time.
The self-supervised aspect eliminates what's been a major bottleneck in agent deployment. Traditional machine learning requires labeled datasets, but RHO generates its own training signal from execution history. This makes it viable for specialized domains where you can't easily create validation sets, or for custom business applications where the optimal behavior needs to be discovered through experience rather than predetermined.
Exactly, and this addresses something we touched on earlier, the enterprise pilot purgatory problem. One of the reasons organizations struggle to move AI agents from pilots to production is the ongoing maintenance and improvement burden. RHO potentially transforms that from a cost center into a competitive advantage. Your AI agents become assets that appreciate in value through use, rather than depreciating through entropy and edge case accumulation. Let's shift gears from these massive enterprise AI systems to something you can actually build on your desk this weekend. There's this fantastic ESP32 project that displays real-time information about aircraft flying overhead, and it's described as really easy to construct. For anyone working with microcontrollers or home automation, this hits that sweet spot of practical and impressive.
What I love about projects like this is how they democratize access to what used to require expensive, specialized equipment. You're essentially building your own personal air traffic control display using a microcontroller that costs under $10 and freely available flight data APIs. It's a perfect example of how the barrier to entry for sophisticated technical projects keeps dropping.
Exactly. And this type of project integrates beautifully with broader home automation setups. If you're already running Home Assistant or similar systems, an aircraft tracker becomes another data source you can incorporate into dashboards, notifications, or automation routines. The ESP32 platform makes it incredibly accessible. You get Wi-Fi connectivity, decent processing power, and a massive community of existing libraries and examples.
This connects to the broader theme we're seeing with Google's Gemma 4 Builder Stories. They're showcasing 3 independent developers who've built real production applications using these open models. What's significant is that Google is positioning open source models as genuinely competitive alternatives to proprietary APIs, not just academic curiosities or toy projects.
The timing is interesting too. Google is clearly pushing their open model strategy ahead of major competitive releases. For builders working on AI-assisted businesses, this represents a fundamentally different economic model. Instead of ongoing per-token costs that can make or break your margins, you get the computational capability up front and run it locally. Combined with models like Gemma 4 12B that fit on consumer hardware, you can build sophisticated AI applications without recurring cloud dependencies.
What's remarkable is how these 2 examples, the ESP32 tracker and the Gemma 4 implementations, represent the same trend from different angles. Hardware is getting more capable and accessible, AI models are becoming more powerful and affordable, and the tools and frameworks keep getting easier to use. We're seeing the democratization of capabilities that were exclusive to well-funded teams just a few years ago. For solo builders, this isn't just about lower costs, it's about creative freedom and the ability to experiment without massive upfront investments. Now let's look at 2 fascinating applications where AI meets traditional business domains. First up is something called the RSI Neural Engine for TradingView. And what's remarkable about this isn't just that it's implementing AI in trading, it's that it's implementing an actual neural network with full transparency. We're talking about visible weight matrices, gradients, and a live learning loop that trains bar by bar right on your chart.
The transparency aspect is what makes this so different from typical AI trading tools that are basically black boxes. This system shows you exactly what it's doing: forward pass, back propagation, Adam optimizer, softmax outputs. It feeds RSI data through 6 dimensions: the value itself, slope, acceleration, fast-slow spread, percentile ranking, and volatility, plus higher timeframe context. And it paints conviction-weighted signals directly onto the candles based on actual probability outputs.
What I find technically impressive is the honest approach to model validation. Instead of hiding behind marketing claims, it includes a live dashboard showing probabilities, accuracy metrics, sample counts, and input influence weights. Most importantly, it displays out-of-sample accuracy, and if that doesn't beat the baseline, the model literally tells you the market structure isn't predictable right now. That's refreshingly honest for a trading tool.
Right, and the practical implementation is smart too. It has tunable parameters like forecast horizon that you match to your actual holding period, move threshold for filtering out noise using ATR, and a neutral zone to avoid trading in choppy conditions. The conviction-coloured candles, green for bullish, red for bearish, faded for low confidence, give you a clear stand-aside signal when the model isn't confident. It learns from scratch on each chart and needs about 200-300 bars to warm up before it starts making predictions.
This connects to a broader strategic challenge that's addressed in the strategic centering framework. Traditional strategy tools like Porter's Five Forces or BCG matrices assume stable industry boundaries and tangible assets, but in dematerializing economies where value shifts to data, software, and capabilities, those frameworks break down. How do you allocate resources across a portfolio when you're comparing completely different types of intangible investments?
Strategic centering offers a solution by choosing a single organizing principle that guides all allocation decisions across seemingly unrelated businesses. The example given is eye care and pharma, totally different industries, but if your organizing principle is something like improving human biological capabilities, suddenly you have consistent criteria for comparing a consumer health factory investment against pharmaceutical R&D spending. It reduces decision latency and eliminates the political friction that comes from trying to compare apples to oranges.
What's particularly relevant is how this framework addresses portfolio management in an age of rapid experimentation. Whether you're running multiple small AI-assisted businesses or trying to allocate between trading, software development, and other ventures, having that clear organizing principle prevents paralysis when facing diverse opportunities. Instead of getting stuck comparing unlike investments, you evaluate everything against your unified strategic center.
Exactly, and both of these tools, the RSI Neural Engine and Strategic Centering, share this theme of bringing systematic, transparent decision-making to traditionally subjective domains. The trading tool makes market analysis explicit and auditable, while the strategic framework makes portfolio allocation decisions systematic rather than political. For builders managing multiple projects or investment streams, these represent practical frameworks for making better decisions faster, which is crucial when you're operating across diverse domains simultaneously.
So when we step back and look at everything we've covered today, there's this fascinating paradox playing out. On one side, we have 75% of enterprises claiming they're adopting agentic AI, but remaining stuck in pilot mode. On the other side, we're seeing genuinely autonomous systems like Fable 5 handling multi-day coding projects, self-improving agents through RHO, and Anthropic achieving 80% AI-authored production code. The capabilities are racing ahead, while organizational adoption lags behind.
Exactly, and what's really striking is how this creates this massive opportunity for individual builders and smaller teams. While enterprises are paralyzed by procurement processes and risk management, solo builders can just start using these tools today. The democratization aspect is incredible. You've got Gemma 412B running multimodal AI on laptops, ESP32 projects you can build in a weekend, and open models that compete with proprietary systems. The barrier to entry for sophisticated AI applications has essentially collapsed.
That democratization trend suggests we're entering a fundamentally different phase of AI adoption. Instead of the traditional enterprise-led rollout pattern, we might see innovation coming from the edges, individual developers, small businesses, and specialized applications that larger organizations can't or won't tackle. Google's strategy of attacking multiple segments simultaneously with live translation, business tools, and local models seems to recognize this shift.
Right. And the self-improvement capabilities we're seeing with systems like RHO suggest that the AI tools available today will be substantially better 6 months from now, not because of new releases, but because they'll have learned from deployment. That changes the calculus completely. Waiting for the perfect solution means missing out on systems that get better through use. For the second half of 2026, I think we'll see this divide between enterprise caution and builder innovation really accelerate.
The technical capabilities we're seeing, multi-day autonomous operation, recursive self-improvement, transparent neural networks running in trading platforms, these aren't incremental improvements. They represent a phase transition in what's possible with AI assistance. Combined with the economic accessibility through open models and consumer hardware, we're looking at a period where individual builders might outpace entire corporate AI initiatives simply because they can move faster and iterate more freely.
That's exactly right. And for anyone listening who's been waiting for the right moment to start building with AI, whether that's automating their business processes, creating new products, or just experimenting with these capabilities, the infrastructure is there, the tools are accessible, and the competitive advantage goes to those who start learning by doing rather than waiting for permission. The second half of 2026 is shaping up to be fascinating. Thanks for diving deep into all these developments with me today, Oliver.
Absolutely, Jane. The gap between what's technically possible and what's being deployed in practice has never been wider, which means the opportunities have never been greater for those willing to bridge that gap. We'll be back tomorrow with more insights from the rapidly evolving world of AI and technology. Until then, keep building.